Okay, so today's about the last major rule in the course for this chapter, for the first half of the course, the chain rule. General discussion about how these functions are formed, what is the same about them, what is different about them. Well, they all have x squared in them, Mr. F, and they all have sine in them, but the first two are very different than the last two. The first two are the product of two functions. The next one is the difference or the quotient of two functions. But the last two are functions of functions. Okay, they're not the same. Sine squared x means sine x all squared. Okay, that's just notation creeping into math language and saying that this means the same as that. So what is the difference? They all have x's, they all have sines, they all have squared components. The first one is the product rule, the second one is the quotient rule, and the last two are the chain rule. So when you have functions within functions, you need to use the chain rule. Yeah, same idea, logs within logs. You'd actually use the chain rule, but we're not going to talk about that for a while yet. So we'd use the product rule for this one, product rule, quotient rule, and then these ones are chain rules. Okay. Because they have functions within functions. So the first thing we need to do is to practice to identify what the inside function is and what the outside function is. So y equals tan squared x, we probably should write it like this first, so we can identify what the inside function is and what the outside function is. The inside function is tan x, and the outside function is, well, it's bracket squared, and then we typically, so you could even just go, Mr. F, it's the squared stuff. You know what I mean? Okay, next one. What's the inside function? X squared plus 9. What's the outside? Cos of the stuff. So cos x if you want to put it there, but it's the cosine function. Okay, then, well, I'm not gonna actually ask you to identify the inside and the outside. I'm just going to ask you to recognize that there is something outside and there is something inside. That's important. Okay, I'm not going to say identify the outside function and identify the inside function. I'm just going to ask you to work with it. Okay, so the last one, you would say x squared plus 10 is the inside, and the outside is the bracket to the power of 15. And you could put x there or f of x there or whatever you want. I really don't care. Are there any more after that? Oh, tan of sine of x. So the inside is sine x, and the outside is tan of whatever. Ooh, E. E is being tricky. The inside x, and the outside is tan of blah, sine of blah. It is crazy. But are we okay with identifying what the inside and what the outside is? Yeah, okay. Consider the function 3x squared plus 1 all squared, determine y prime. So I'm pretending right now that you don't know the chain rule, because you don't. So the only rule that you can use right now is the product rule. Actually, you can also do the power rule here as well. So I guess we have three ways of doing this. The first way that I would suggest you do this is to change how the function looks. get all math 12 and 11 on it and say, Mr. Up, the power of 2 means 3 squared x squared plus right? So then you could get all product rule on it. The derivative of the first is 3x squared plus 1. The derivative of the first is 6x. The second is 3x squared plus 1. The derivative of the second is 6x. Yes? So put it all together, get all product rule on it. Derivative of the first, 6x, times the second, 3x squared plus 1, plus the derivative of x times the first. Why is it moving over there? 3x squared plus 1. Yes? Multiply that out, because it's fun. 18x cubed plus 6x plus 18x cubed plus 6x. 18 and 18 is 36x cubed plus 12x. How was that? Easy? Okay. Flip the page. The extended power rule. Instead of doing what we just did, there's another way of doing it. And this is the first part of the chain rule. And I'm going to say it in a formula, and then I'm going to say it in words. In the formula context, you use the power rule to drop the n down. N times u to the n minus 1 times u prime. Because that means the same thing. Yep. If I read it as y equals u to the n, then dy over dx would equal this. But if I just start with u to the n as an expression, and I want to take the derivative of it, I don't need to make it dy over dx. It's just d over dx means derivative as well. They all mean derivative. So if we go back to the previous example was 3x squared to the plus 1 to the power of 2. The extended power rule says drop the 2 down, leave the brackets alone, change the 2 to a 1, and then multiply it by the derivative of this bad boy, 6x. So you're thinking to yourself, well, that's strange, but I'm going to do a little bit of cleaning up. 2 times 6x is 12x, 3x squared plus 1. Mr. Up, you can get rid of your brackets here. 12 times 3 is 36, x cubed. 12 times 1 is 12x. Look at the previous page. Dun dun dun. Same answer. This is the chain rule. It is a part of the chain rule. So the chain rule that I remember, and we need to flip back to the previous page to look at the words again. See the words inside and outside? The way that I define the chain rule is like this. The derivative of the outside, leave the inside alone, times the derivative of the inside. What? Say that again. The chain rule is the derivative of the outside, leave the inside alone, times the derivative of the inside. Can you see why I practiced what outside was and what inside was? Well, I'm saying that a little bit fast because that's the leave the inside alone business. So the derivative of the outside, the 2 becomes a 1. Leave the inside alone times the derivative of the inside. Do you like the formula better than the words? Fine. Fine. So, determine the derivative of each of the functions. Well, Mr. F, I don't like this notation because it scares me when I have to take derivatives of it, so we'll write it like this. What's the derivative? Derivative of the outside times the derivative of the inside. But can you see why I don't say the derivative of the outside times the derivative of the inside? I have to actually say derivative of the outside, and then I say really fast, leave the inside alone. And then times the derivative of the outside. Sorry, inside. Out and then in. Okay? Yeah? You down with that? I am so down with that, Mr. Rapp. Okay, B. What's B as I scroll? Oh, Miss App. You're trying to make me do extra work with the quotient rule. How about doing this? Which is probably why I didn't bother to learn the quotient rule the first time. Because I just went, cool, I'll flip it up. And I don't have to remember the quotient rule. Right? Because any quotient can be written as the product of 2 items, one of which is its reciprocal. Gotta love Math 8, right? Who divides anymore? Products were suckers. So y prime is, you guys got an answer there? Oh, you went way too, okay, so I want to do this in 2 steps. What's the first step? Times 2x. Good, and then you cleaned it up a little bit more, and you wrote it like negative 6x times x squared plus 1 to the negative 4. And then if I was all cool about it, I could write it as, you could change it back into some fraction looking thing, because to be able to do that, you should be able to go, hey, to me, no. To the AP exam, maybe. I see it all as the same thing. Do I want to talk about the stupid mistake kids make when they do these? Don't do this. So you start here. Don't do this. This is embarrassing. Can you see what I did? I did the derivative of the outside, and then on the inside is the derivative of the inside. I didn't... Know what I mean? Like, can you see the mistake now? Don't... This... That... Add... Bad. Don't do it. It's silly. Anyway. I will laugh at you. I will put you in the penalty box if you do that. Okay, C. You are not gonna like me. Can anybody predict why this one's gonna be not in the liking mode? Oh, it's got all sorts of good stuff going on. Derivative of the outside, 2, open a bracket, cos x over 1 plus sine x to the power of 1 times dun, dun, dun. Now, if you're really good, you can start writing the answer down. If you're like me, you have to actually write down what you're about to do. Mr. App, I'm about to do the... Come on, say it with me. I said it this morning all dorky-like. No, that's not dorky-like. Quotient Rule! Oh no, Mr. Bill! Top is equal to cos x. Top prime is equal to negative sine x. Bottom is equal to 1 plus sine x. Bottom prime is equal to cos x. Derivative of the top minus sine x times the bottom 1 plus sine x. Minus the derivative of the bottom minus cos x, y'all, times the top. Well, you gotta get excited because this is pretty boring. All over the bottom squared. Ugh. Well, do you want me to clean it up? Because it will. Okay, so we're going to get all ditto marks on this because this is just silly to copy them. So when you multiply in the negative sine x to that, you get negative sine x minus sine squared x minus cos squared x all over 1 plus sine x squared. And then you can say, hey, cool, Mr. App, this is negative 1. Negative 1. I could factor a negative out and it would be negative bracket sine squared plus cos squared. I'm just skipping a step. That your Math 12 teacher, as evil as he is, he wouldn't have let you do that. He would have made you factor and then substitute the 2 different steps. I've heard about him. He's not very nice. Anyways, anywho, what did you guys put in my coffee? 2 cos x bracket negative sine x minus 1 all over 1 plus sine x cubed. You guys okay with the cube is coming from? Where? Because there's a sine 1 plus sine x down here, and there's a 1 plus sine x squared down there, so you can put them all together and call it a 1 plus sine x cubed. I like this question because it makes you do the quotient rule inside of the chain rule, but I don't like this question because it's messy. You know what I'm, so I like the skill that it's making you use, but I don't gonna make it this messy on your test. Do you kind of know what I'm saying here? Like, I like the quotient rule inside. I like the quotient and chain rule when they blend together. I like the product rule and the chain rule when they blend together. When you use the product rule after you've done the chain rule. Greg. How many marks would this be worth on your test? Probably about 3. Well, okay, like, why are you trying to avoid? Like, that's only 3 steps. It's only 3. The first step is you using the rule and not doing anything with it. The second step is you attempting to clean it up. And then the third step is you going, hey, cool, Pythagorean identity. That's awesome. Getting all Math 12 in its face, right? Mitch. You will hate me. It starts with a letter N, ends with a letter O. I would love to provide you a formula sheet. Like, seriously, I think it's a little bit unfair that they don't give you any identities or any formulas. From what I've seen on practice exams, no. The basic ones. Like, if you remember from Math 12, sine squared plus cos squared equals 1, like, that's the only, have you noticed that? That's the only one that seems to be coming up again and again and again. Well, the double angle ones, yes, but those we'll go over again later when I need them. But not all of the double angle ones. The reason I use double angle ones is to make the derivatives easier. Well, it's either do you want to use the product rule or would you rather use the chain rule? Chain rule is faster. Okay. So plot the function y equals sine x and the derivative of the function. Okay. Using your calculator, show the graph on the axis below. Okay, so you got that there? You got that on the next page? So we're going to get our calculator to graph the function and its derivative at the same time. So y equals sine x. Now we can get the calculator to graph its derivative by going math over, where's derivative? I think it's right here. N deriv. And then you're going to get it to put y1. Maybe you just want to watch. y1 vars over to y vars, function y1, comma x, comma x. So you can get the calculator to graph a function and its derivative at the same time. What is the variable and where are you finding the derivative at? So it's going to do it numerically each time. It's going to use the symmetric difference quotient. So it's going to just, the last one is usually it's the number where we're taking the derivative, but because we're taking the derivative everywhere, we need to say x. Okay, window setting. We're going to use 0 and 2 pi and -2 and +2. Okay, so it's going to graph sine right now, and then it's going to graph its derivative everywhere. Hey, Mr. App, it's graphing cos. We did this yesterday, right? Well, it's because it's doing it numerically, and it's got to do the slope calculation. It's got to do that y2 minus y1 over x2 minus x1 for every single point, and that's why. That's why it's doing it slower, because it's not really graphing cos. It's really doing a slope calculation for every point and plotting the slope. That's why it's slow. Okay, so I want you to draw sine x. So this is y equals sine x. Y equals sine x. And then it's going to graph its derivative. We'll just say y prime equals. But we know it's cos, but we were supposed to pretend like that we weren't really quite sure. Okay? Vars over to y vars, and it's in the function menu. But like I said, it's not important. Yeah, sure. Okay, B. Now change y1 to sine 2x. So hit y equals, change that sine x to 2x. Okay, I'm going to graph the function y equals sine 2x on here. You should say, Mr. App, that is the sine graph that's been horizontally compressed by a half. So that yellow graph will be sucked back towards the x-axis, and it will look like this. The period has gone from 2 pi down to pi. This is the graph that never ends. It goes on and on, my friends. Anyway, y equals sine 2x. Now I'm going to get the calculator to draw its derivative. Ready to be amazed? Astounded? How about now? Ready? I'll get up mathy in its face. Graph. Yeah, just change the x. No, it'll just do it numerically. A big code. It's that graph been vertically expanded by 2. 2. 2. Boo, 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 2. 2. 2. It's also been horizontally compressed, Mr. F. It's y prime, and we can recognize it as a cos graph, and it's been vertically expanded by 2, and it's been horizontally compressed by 1/2. Is that one of those moment? Yeah? Do you want to see why now, or do you care? You care? Okay, I'll let you draw your picture, and then I'll say I care too. I'll show you why. Okay. So y equals sine 2x. Here's the part where you go, Mr. Epps. 2 cos 2x. So we could also write y like this. 2 sine x cos x. What rule did Mr. Epps just use? Double angle identity, right? We're going to use the product rule now. We're going to put the 2 down, we're going to cover it up with our thumb, and we're going to use the product rule. The derivative of the first. Cos x. The second is cos. The derivative of the second is minus sine. Okay, I'm about to use the product rule for this, just the highlighted stuff. Look, I'll even use bracket. Oh, here. Just the highlighted stuff. Here we go. Product rule. Derivative first, cos x, times the second, cos x, minus plus the derivative of the second, minus sine x, times the first, sine x. Hey, looky, cos squared minus sine squared, cos 2x. Double angle identity again, going the other way. Double angle identities, kids. That's actually the justification. That's actually how you prove that the derivative of sine 2x is 2 cos 2x. You need a double angle identity to do it. Actually, you need both double angle. Is that the reason why we learned that in Math 12, Mr. App? Coincidence? No. You all right? No. No, I'm just showing you where it comes from. I'll look at the AP exam closely and see, but my reaction right now is it's better to say yes now and then to say no later than to say no now and yes later. But this is where it comes from. Cool? Now, what do I ask you to do is to just to say, Mr. App, it's just an additional little bit to the chain rule. We can just, because the derivative of sine is cos. Whoa. What? Yeah. We're not talking about phase shift. We're talking about horizontal expansion and compressions.
No, but like just for the regular one without it.
You mean the derivative of sine is sine with a phase shift? Do you want it? It does, but I don't think anybody else in the room wants to say that, including me. Yes, you could, but that would hurt people's brains. The derivative of sine is sine of x minus pi over 2. People might cry if I did that. Okay, I won't. The derivative of sine is cos. And the derivative of sine 2x, we just learned, was 2 cos 2x. Now, App's starting to hint here. I might call the outside sine and the inside 2x. Can you see how you might use, I've been saying the chain rule already. The chain rule for me is the derivative of the outside, leave the inside alone, times the derivative of the inside. The derivative of sine is cos, leave the inside alone, times the derivative of the inside. Now, can you see how I say the chain rule is a better way than to use those rules? Because you already know the derivative rules. All I'm doing is adding some context to add it deal with when you have brackets. Derivative of the outside, leave the inside alone, times the derivative of the inside.
So, like,
Cam had his Cam. No, you can never get out of using the product rule. You can get out of using the quotient rule by flipping stuff up off the denominator, which is what I did, but it made things so messy sometimes. Now that I sit back as a teacher, I'm going, what the heck was I thinking? Well, I guess you could say, Mr. Epp, I only need to know 2 rules then, but it gets more cluttered. Alana. Okay, flip the page. So the derivative of 5 cos x. So what I'm saying to you is cos x is the outside, or cos is the outside, is the out, and the in is 5x. So I guess you need to figure out what the derivative of the outside is, negative sine x, and the derivative of the inside is 5. Okay, now put it into the rule that I've been saying. Okay, don't jump to the answer though. Like, just derivative of the outside. What do I put in the brackets? Leave the inside alone, times the derivative of the inside. So then you would write it as negative 5 sine 5x, and you're finished. Can you see now why I made you go and write what out and in were now? It's actually saving you time. So what's the out on this one? Oh, Mr. Epp's even being nicer, he's hinting. And the in is x squared. So what's the derivative? Okay, so you're writing it the way that we would see it in the answer key. Yeah. We typically put our trig stuff last. Easy now? See what we're doing? Okay, do the next one without me hinting. You got the answer? What freaks you out is I can do this in my head. But I've been doing it a lot longer than you have. What? Well, and what you would see me do is when I actually did this as a student, you would see me circle the inside and actually have an arrow so that I knew that I was doing the derivative of it. That maybe that circle and the arrow helps you see that. That circle and the arrow is the derivative of the inside happening. Is that's another, it's a visual way of seeing it. Is that it for those, or are there more? One more? This is so exciting. The derivative of secant squared. Oh, crap. Okay, secant squared. The second derivative of this one is not nice, because you got to do the chain rule again. It's a chain of the chain. It's a chain squared rule. You're like looking at it going, it's the first chain rule. So if I asked you to do the second derivative of this, which I'm not going to, you would have to see the function like this. Like that. So then, okay, so we'll do it. So you put the 2 down, you cover it up with your thumb, you drop this 2 out front, and then you do the derivative of this inside, and then you do the derivative of this inside. So it's 2 times 2 times 2. That hurts your brain, doesn't it? Yeah, I'm going to eventually, yeah. The derivative of secant is secant tan. Oh, is that a little bit of a whine there? I thought I heard a little bit of a whine. Aw, pudding. It'll be just fine. Yeah, well, this is fun. In a weird mathy sort of way, this is fun. Anyways. Okay. We're not in Kansas anymore. New rules for composite trig functions. So, if you really want more rules, here's some more rules. So the derivative of sine is cos. And then the derivative of the inside is u prime. We've already been doing these. The derivative of the outside is cos. The derivative of the inside is u prime. So what's the one on the right going to be? So tan is secant squared u times u prime. Secant u is secant u tan u times u prime. I have a really bad joke I could tell you, but I'd have to close the doors and stop the recording and u times u prime. Negative cosecant u cotan u is u prime. You know what's scary is I just looked them up this morning and I have them memorized again. All that useless trivia. But I think I got the stupid Katy Perry song out of my head finally. Oh. Now I'm going to start singing it again. No! Stupid. I have no idea. Oh my God, you got it in my head again. I want it out. I'm going to use a sharp drill. Oh, I'm sure I could find it real fast. Okay. So the derivative of sine x cubed dy over dx is going to be cos x cubed times 3x squared. Hey, wait, we've already been doing this. Flip the page. I'm sure there's lots more. Now we'll just pick through these, unless you're excited and want to do all of them. Oh, this one's exciting already. Sine of cos of x. This one's cool. We're already at C. Sine of cos of x? Sine of cos of x? Well, where's B? Oh, there it is. Oh, B bracket sine x bracket cubed. So it would be 3 bracket sine x bracket squared times cos x. That's boring. Boring. Okay, what's C? That's exciting. So it would be cos of x times negative sine x. Yeah. And you're done. Can't do anything with that. It's cos of x. It's not cos squared x. Nah. It's cos of x. Okay, what's D? What? Because I'm using... Okay. I just went up to tell you why. Okay, derivative of tan. Secant squared. Did you know that? 2 in the fifth? Awesome. Thank you. Derivative of 3x minus x squared. Three minus 2x and you're done. What's E? These are fun. No, they're not. They suck. Y equals cosecant x plus cotan x. Y prime equals, drop the negative 1 down, cosecant x, this one sucks, cotan x to the negative 2 times, open a bracket, and then yucky. This one is not nice. Who's putting this on? This is John. Negative cosecant x cotan x minus cosecant squared x. John, why do you pick such an awful question? Oh, okay. So I might be freaking you out that I have those memorized already. Yeah, but okay, how many years have I doing this for? Oh, okay, yeah. When did I graduate from high school? You weren't even born yet. Oh, maybe. I started doing calculus in 1990. You weren't even born yet, okay? So I've been doing these kinds of things for, yeah. Yeah, so let's just put it this way. I should be good at this, right? Well, it'd be pretty funny if I wasn't. What? Are you kidding? This is not boring. This is exciting. When you're an uber nerd like me, this is cool. Okay, F. Product rule. Product rule. Product rule. Okay, what's U prime? 2x. What's V prime? You just did the chain of the chain. You did the chain in the chain. You can't do that. Can't do that, man. Cos x squared plus 3 times 2x. No. We can do the chain rule inside of the product rule. What Aaron was doing was the chain inside the chain and forgot about the chain rule. Can you put all the pieces down in the puzzle now? You get puzzled with the puzzle? Y prime equals. We just got 4 brackets to drop down. There. I don't know if I got enough space. Y prime equals U prime times B. I'm getting silly now. Getting? Why do you get all those extra brackets? U prime times V plus V prime. Anybody started dreaming about calculus yet? I didn't look for hands. Hands? V prime times U. Get the idea? We're not going to do all of these. We're just going to talk about, we're going to stop. So, T is sine x. What's B? Secant 2x. T. What's B prime? Yeah, I guess you can do that, but I didn't need to do that. Okay, fine. Be that way. Yeah, you could have just done that too. Fine. Jerk. You like that better? Okay, what about H? What's T? I'm hearing people better do these. T is x squared plus 6. What's T prime? 2x. I'm going to stop after this one. No, I don't want to. Fine, be that way. I'm not going to write it down then. I'm going to hold my breath. Sometimes. B equals brackets fourth. I'll zoom out. I can't zoom out. I just got told. Why? What's happening? I got excited. I hate this computer right now. I hate you. You're too slow. Okay, there's G. Now, so we're doing H. Maybe I can have G and H on the screen at the same time. Gonna try for that. So B is sine x to the fourth. So B prime is 4 sine x to the power of 3 times cos x. And then you put it into the formula and you drop everything where it needs to go and it's all good. Okay, what's the last page? Not that it matters right now. Who cares? Yeah, we'll do that. We'll maybe do some of those tomorrow when you're done. No, not those. So tomorrow we're going to finish off the chain rule. Because we get technical, and then, so my goal for Friday is to be done up to the end of 3-7. So that kind of gets most of the rules done and out of the way, and then all we got chapters 5 and 6. And a little bit of 7. That's what the AP course is. It's 3 and 4. It's 2, 3, 4. And then 5, 6, 7. See that 2, 3, 4 are all one theme, 5, 6, 7 are all another theme. Well, so we have to do 6 and then 5 and then 7 because 5 doesn't really make. I could do 5 I could do 5 without talking about 6, but I want to have some context for why 5 happened.